Algebra 2 Notes, 8.2 Graphing Reciprocal Functions. So if we review the functions we've done this year, we've been able to graph a linear function, which is a line. We've been able to graph a quadratic function, which was the parabola. Absolute value, which is that V shape. Radical function, which was the sideways parabola. And then exponential, which grows bigger and bigger. So we have one additional function to add. It's called the reciprocal function. Okay. Now, just like when we look at this absolute value, how there's x minus h plus k, and the radical x minus h plus k, and the exponential x minus h plus k, those h and k's move it left, right, up, and down. Same thing with the reciprocal function. So first of all, let's graph the parent function, and then we'll be able to move it left, right, up, and down. So let's go ahead and make a table of values. So if our function is 1 over x, we could just plug in a couple points. So 1 over negative 3 would be negative 1/3. 1 over 2 would be negative 1/2. Negative 1. Okay, here's this one. We had this one come up in 8.1. 1 over 0, we can't divide something by 0. So that's going to be that undefined term, and that's going to be the spot where those asymptotes show up. Okay, if we plug 1 in, 1, 2 in, 1/2, 3 in, 1/3. And actually, I might plug in a couple other points, maybe like 1/2, just so we can see what happens. If I do 1 divided by 1/2, let's see, 1 divided by 1/2, that's the same thing as multiplying by the reciprocal. So it's actually going to be 2. 1 divided by 1/2 would be 2. That'll kind of help us out, see what this graph's going to do. All right, so let's go ahead and plot these points. So negative 3, negative 1/3, negative 2, negative 1/2, negative 1, negative 1. If I kept going negative 1/2, it'd be negative 2. Negative 1/3, it'd be 3, and so on. Okay, and then the positive points here, we have 1, 1, 2, 1/2, 3, 1/3, 4, 1/4, if I wanted to keep going, 1/5, 1/6. And then also if I did 1/2, it's up 2. If I did 1/3, it's up 3. 1/4, it's up 4, and so on. So this one, remember, at that undefined term, when x is undefined, there's going to be an asymptote. So let's draw those in there. I'm going to do those in red, I think. Let's try that. A little bit thicker. Okay, so we can do an asymptote at x equals 0. That's going to be the vertical asymptote. But then there's also one at y equals 0. So when it says, what are your asymptotes? We have one at x equals 0. That's the vertical asymptote, because the x value is always 0. We're never going left or right. We're always going 0. And then y equals 0, that's the horizontal asymptote. So then if we kind of sketch this out, again, this line's going to approach that red line, but it's not actually going to cross over it. It's going to get closer and closer and closer, but it's never going to cross. Same thing up here. All right, so remember for our graph, we've got the y-axis and the x-axis. So if we want to know what is the x-intercept, where does that blue line cross the x-axis? So that's that horizontal axis. It doesn't, so we say none. Okay? Where does that blue line cross the y-axis? Again, none. But if as I move my graph left and right, up and down, it will end up crossing. All right, now what is the domain? So as I go left to right, what can x be? So we've got an x value for all of these points. This blue line is all represented except for when you're at 0. And then again, it's represented. Or you can think, what could I put in for x? The only one that didn't work was when we had that 0, because that was undefined. So for the domain, we say all reals except x does not equal 0. Okay, x equals 0 is the one that doesn't work. And then the range, if I go from the bottom to the top, again, there's that asymptote at y equals 0. So say all reals except for y equals 0. All right, let's see what happens if I move this function. So just like when we've had the different transformations with all these different functions, when the number is in the function, so like this 1, we're going to do the opposite sign and it's going to move it left and right. When the number's outside the function, we're going to move it up and down. So this one would be your original parent graph, just like up above, but left 1, and then down 2. Okay, so if I move this whole function left 1 and down 2, then my asymptotes now are also moving left 1 and down 2. So we move left 1 and then down 2. There's my new function. All right, so when you make these points, you can go ahead and make the chart, or you can kind of use that parent function to just move each point left 1 and down 2. So this point that was at 1, 1, if I move it left 1 and down 2, now it's going to be right there. Okay, so there's my 1, 1, and then it's from there it's going to go 2, a half, 3, a third, 4, a fourth, and so on. Or 1/2, 2, 1/3, 3, and so on. Okay, and then just do the mirror image of it down here. If that's confusing, you can always make the chart and fill in points to get it to work out too. All right, so let's go ahead and connect the dots. So on your homework, I do want you to be precise with the points, not just a sketch. Make sure you add in some of those points. If you're having trouble just kind of figuring out where those points are, then just plug them back into that original equation. For example, if I put 1 into the equation, 1 over 1 plus 1 minus 2. So 1 over 1/2 minus 2. So it would be negative 1.5, which is where our point is. 1, negative 1.5. All right, so then the domain. So again, the only value that's not going to work is where that asymptote was. So all reals except x equals negative 1. Range, so what can y be? All reals except, why don't you guys fill in the blank? What should y be? Or what can't y be, I should say. Okay, the vertical asymptote, that's going to be your x equals. Horizontal, that's going to be your y equals. Okay, so the range, all reals except, so if I go from the bottom to the top, that red line, we moved it down 2. So all reals except y equals negative 2. So then vertical asymptote is at negative 1. Horizontal asymptote, we had to move down 1, 2. Y equals negative 2. Okay, now what is the y-intercept and the x-intercept? This one's a little trickier than the first one we had. All right, couple ways to figure this out. If you can just tell by your graph, because this is my y-axis and this is my x-axis, that the y-intercept is 0, negative 1, you can do it that way. And the x-intercept is negative 1/2, 0. So if you can tell it, just go ahead and figure out what they are. But if you're having trouble seeing what they are, because it's going to be one of those fraction answers, what you can do is find the y-intercept by letting x equal 0. So we could take that original function and put 0 in for x. So we had y equals 1 over, put a 0 in for x, and continue. Okay, so it becomes 1 over 1 minus 2, or just negative 1. So that's what we got. X is 0, y is negative 1. Yep, we already got that. Okay, so to find the x-intercept, just do the same thing. This time, plug in 0 for y. So if we take that function, we're going to go 0 equals 1 plus x plus 1 minus 2. This one's a little trickier to solve, but we can add the 2 right away. And then we can cross multiply if you want. Think of that as over 1, and you can multiply the cross products. So we have 2 times x plus 1 equals 1. If we distribute, and keep going by solving that. So this is the way, if you can't tell it with your graph, you can always just let y equal 0 to find the x-intercept and vice versa to find the y-intercept. So we got x is negative 1/2 when y is 0. Well, if I look at my y-intercept, or my x-intercept, that's what I already got for it. Negative 1/2 and 0. All right. Why don't you guys try example 2, and then go ahead and pause your video, see if you can come up with that one, and then I'll put the answers up here shortly. All right, go ahead and check your graph. Now I'm going to show you how we can find the x and y-intercept by kind of doing this counting technique. So we've got the y-axis up here. So if I want to count my intercept, my y-intercept, so this was 1 away, right? From that horizontal asymptote. And then we had a 1/2, and then we had a 1/3, and then we had a 4th. So if that point is a 4th below the red line, that means it's up 1, 2, 3, 4, 5, and 3/4. So my y-intercept is going to be 0, 5, and 3/4. You could solve that algebraically as well, just like we did in the previous one. My x-intercept, okay, so this one was 1 away from the vertical asymptote, 1/2, 1/3, 1/4, 1/5, and 1/6. So 1/6 away. So it's over 1, 2, 3, and 5, 6. 3 and 5, 6, 0. Okay, now again, if that doesn't work, you could just plug in 0 for x to get your y-intercept and plug in 0 for y to get your x-intercept. All right, you guys can get started with the assignment. It's just 4 problems, just doing the same thing we've been doing. Figuring out the domain, range, horizontal asymptote, vertical asymptote, y-intercept, x-intercept, and graphing.